how does this paternal transmission actually happen? We can break it down into 4 steps. First, the father's obesity is the environmental exposure. This exposure then alters the epigenome of his sperm. Third, at fertilization, this altered epigenetic information gets transmitted to the embryo. And fourth, this leads to modified gene expression in the child, especially in genes that are responsible for things like appetite control. Okay, so once we understand these mechanisms, the role of nutrition starts to make a lot of sense. Take the standard American diet, for example, which is high in refined carbs and trans fats. We see a clear association with a higher risk of infertility related to ovulation. On the flip side, what we might call a pro-fertility diet, one that's high in fiber, omega-3s, and protein from vegetables, is associated with a lower risk. And here's something important. The interventions don't always have to be drastic. For women whose fertility is impacted by inflammation linked to obesity, losing only 5% of their body weight can be enough. That modest change can reduce the chronic low-grade inflammation and, in many cases, restore ovulation. That's a huge clinical benefit for a relatively small change. Now, for men, we can get even more specific and look at certain bioactive compounds. Take selenium. It acts as an antioxidant, which helps reduce oxidative stress inside the sperm cells.